Hello, my Math 106 students. I hope you're excited to tackle this project. I'm going to start just by talking about the rough draft, which is due this week, and kind of go through some of the steps and make sure you're clear on where everything is and what everything means. So you'll notice when you go into the classroom, it's this page right here. Sorry, I do have several windows because I have a lot prepared to show you. You have the project template, which is this sheet right here. This live by this. I have students who don't answer all the questions on this and they lose points. So make sure you're answering every single question on this page, and I'm going to go through all of them. But for the rough draft, you are going to be doing steps 1 through 3. So that's the part that you're really going to focus on. Now note, this says write as a submit and report. Please don't write step 1, blah, blah, blah. Step 2, I want it as a report like you were going to send to your English teacher. And then later we'll look at 4, 5, and 6 once we get past the rough draft. Okay, so now you have this outline that you're going to follow, but what are you using? There will be provided options. So you are going to have these data sets. The first thing I need to point out are the tabs at the bottom. You have 4 choices. Don't just choose one and then choose some within it. You need to use the entire data set. So I just want to talk about what these data sets actually mean just for a second, because I feel like if you have the correct idea of what you're doing, that will help. So this data set says that, okay, in month number 0, there were 4 inches of rain. Now, what does that actually mean? This tells me at the top that January is the month 0. So in January, in this city in Utah, be nice if they told us which town, there were 4 inches of rain. And then 11 means December. December there were 2. Now notice, Utah has many desert areas, so it's not surprising that some of these numbers are low. So in month 0, so what we're looking at is that the rain starts kind of high in January, then it looks like a very dry summer. Having lived in Utah for a few years in my life, that's fairly accurate. And then mostly you get more precipitation during the winter, get some snow, especially up in the mountains. But that's the idea here, is that you're looking at different months, and the goal of any kind of regression is to be able to predict. We want to see if we can come up with a model that can help us predict the future. Otherwise, there's no value. Now, if we come up with a bad model, that's not going to help either. So if you took Math 104, we did a lot of linear models where you had a constant rate. But if we look at this, it goes down and then up. There's no linear model that goes down and up. Linear models are straight lines. They have one slope and it's constant. So this would not be a great linear model, but maybe it wouldn't be a good quadratic model. And we've been graphing some quadratic functions and they look like U's, right? They're parabolas. They go down and up. So maybe this would be a great example of a quadratic model. So if we look at the exercise benefits, the number of days in a week you exercise, and the benefit. So interestingly, surprisingly, if you don't exercise at all, you get none of the benefit. Now notice it's a scale of 1 to 10, so that's why it's a 1 and not a 0. And then as it goes up, this goes up as well. I do like, if I were looking at something like this, I'd be like, it looks like right around here, it gets up really high and then doesn't kind of grow as much anymore. Which makes sense. If you're exercising a good 3 to 4 days a week, you're going to get some good benefit. And then the rest is probably just for, makes you feel good or helps to maintain. So you can see, but also notice that might be more quadratic, because if it grows quickly and then slows down, that would be more quadratic, but definitely not linear. Linear would be if it goes up at the same number each one. So that goes up by 1, then 2, then 3, and then it goes up by smaller numbers again. So it's definitely not a consistent linear rate. But if you're bored, you can compare them later. Also, things to be noticing is that when we talk about window in our graph, I'm not going to want to graph from 0 to 100 because that would be way too big. And same thing here. We're going to be looking at 0 to 10-ish range and 0 to 10-ish range. I would always recommend, and I'll talk about this later when I do graph, is that you want to have 0, 0 in your graph. It gives you kind of like what's what I'm looking for? A ground. But not always. It just depends on the example. But then you might, like the questions are going to ask you, what are the x values? Now notice, and what are the y values? And that none of these are ever going to be 0 or negative. These can only be positive values. Things like that are going to help you answer those questions later. Carbon monoxide emissions. I actually thought this was interesting. Carbon monoxide emissions went up and peaked in about 1970, and then they started going down. So I'm guessing that this is about the time we started having more cars, and so this started to increase. But then as we realized, oh, we're going to kill our entire ecosystem, we should get that under control, they started coming back down. I mean, that's a guess, but it's kind of fun to think about what causes these numbers to go up and then down. But then you could then try to predict. So maybe I can use this model to predict in 2000 what the carbon emissions will be, or in 2030, or any other thing. And then we can see, okay, do we get it down low enough? When will they be down low enough to take care of our ecosystem better? Sales for jogging running shoes since 1998. So in 1998, so again here, x equals 0 is 1998. So it's important to know what 0 means. And then this is the number of jogging shoes. Notice it is just going up. But having an x equals 0 is actually going to be really important later. So make sure all of these do have an x equals 0. So the first thing that this says, provide an introduction to your data set. So let's say that I really care about running shoes. So I've chosen that I like running. I enjoy running. I buy lots of running shoes. So this interests me just a little bit. Now, when it talks about in the introduction that you want to provide an introduction, why did you choose it? Yes, talk about how you like running and you find, I mean, there are tons of different running shoes out there, but how it is interesting to you, but also what are the benefits of analyzing this data? I mean, for me as a runner, it probably doesn't really benefit me much to analyze this data, but if I wanted to open a shoe store, or if I wanted to open a running store, I would want to know, are sales up? Are sales down? Can I actually make money? Would predicting the future be helpful to me? Because then I can learn whether or not I would need to increase my inventory moving forward and business would increase. So things like that. I want you to actually talk about what the benefit would be. Like if you're looking at carbon monoxide, like we said, we want to know in the future, is this going to continue to go down? Are we going to be able to undo the damage that we did? Or exercising benefit. I want to be able to share this data with other people to show them that if they exercise X number of days, that there's going to be this great benefit for them. Or the first one, sorry, I have to click it over, or the rainfall, knowing rain, well, how's that going to impact the weather, if I want to garden, if I want to do anything. I have family who live in Utah, and they were in a drought for a long time and they couldn't use their sprinkler systems, or it's important. There's a value in being able to analyze data and understand what it's going to do in the future. So that's what you're going to talk about in the introduction. Then you're going to provide a screenshot. Now, I chose to do this with the running shoes, and I definitely don't want you to copy my work, but I want to show you a couple of important things when you go to graph in Desmos. I can find my Desmos graph. So if we graph this in Desmos, these numbers are huge. So I could try to zoom way up here, but I wanted to show you that you can just adjust the window here. So let's say I want to go from -10 to 10, because I really don't need my x's to go very far. Look at the x's, 0 to 6. And then my y's, in general, I like to keep y equals 0 in there, but I'm going to see what this actually looks like if I do that. So it's not too bad in general. And now the nice thing with Desmos is you can just move it around. I do like that about Desmos. I can just, take it and grab it. But I wanted to show you. So looking at this, if you're going to talk about the scale, I have to tell you, why did I not want any negative values? Well, there's not going to be negative shoes sold, obviously. Even though these are really high, you can't sell negative. You could have returns, but in the end, that should cancel out to a 0. Also, we needed higher numbers, so we're going to have to go up here. Let's see, interpretation of the data. Make sure we know what these mean. The X's are tell me the X's are the years. Tell me that Y are the number of shoes in millions. If you look, does this say in millions on the chart? It does, in millions of dollars. Interesting. So it's not the number of shoes. It's the number of dollars that they made in sales. So still it can't be negative, but good to read. And that I didn't check that very clearly. I just dumped the data in here. And you can just copy and paste your data in. And if you're not sure how to do that, you can click the little plus sign, and that's where you're going to find the table. So you're going to click the little table there, and then you can enter your data and see it. And you're going to go through and describe all of these things. Does this look quadratic? Well, it doesn't look like a horrible linear model. I mean, but you can kind of see that it's kind of curving out. So maybe it is more quadratic. Maybe it will start coming down. Who knows? It'll be interesting to determine and to see. But this is a hypothesis. This is, remember, a hypothesis is what you think will happen. So tell me what you think will happen and why you think it will happen. And if you think this would be a good model, maybe you don't think it would be a good model. And that's okay. I mean, you're still going to do the rest of the assignment, but it's okay to be honest and say that you don't think it's a good model. I teach Math 104, and one of the models is horrible. It is not linear in any way, shape, or form. And so it's okay to say, no, that doesn't look linear. It's okay to be honest. I mean, this one's not horrible, but it's not the best either. It would be nice if it went up and then down. So then remember, for your graph, you're going to take your little screenshot and put it in. If you have not mastered the screenshot, now I use a Mac, so I have different functions, so make sure you just Google how to take a screenshot, and then you can just dump it right into. So I mean, if I just take a screenshot here, I like to include the chart. I only like to do that for me, honestly, but that way I can see exactly what it is that you did. And then you can go to a Word document and dump that sucker right in. So you can take it, and maybe you can make it bigger or smaller. But if you keep your, and yeah, as I said, I have a Word. I use a Mac, so my functionality will be a little different from yours. So then you're going to go back. You're going to tell me about your screenshot and all about that. And then you're going to do your quadratic model by hand. And there is a video right here, and it does a beautiful job telling you exactly how to do that. Now, I did actually do this one, but I don't want to show you all of it, obviously. Gotta leave you something to do. And so you must choose. You're going to choose 3 data points, and I would choose one on each end and then one in the middle. But you must use the 0 and the x equals 0. If not, this becomes a problem that you don't want to solve. Just so we're clear, you do not want to solve this if you don't have x equals 0. Because the first time when you plug in x equals 0, you're just going to get the value for c. And then all you have to do is solve for a and b, which makes it much more manageable for this class. I mean, if you were in a different class of mine, way up higher, that starts with the number 2, we could do it the other way, but let's not make a headache. So choose the point that has x equals 0, and then choose 2 other points, one in the middle, one at the end. Set up your equations, watch that video, and have it walk you through. And then when you do get the answer, I'm just going to make up an answer here. This is 1469. So now you can go back here and you can create an equation. So I know that C is 1469, but I just have to create it, the rest of it. I think this looks like it goes upside down. So I'm going to put negative, I'm seriously making this up, plus 0.5x plus this. That's really bad. It doesn't even look close at all. So I wonder if I can, I can just make stuff up, but this isn't going to, maybe I need to make that positive. That looks a little closer. Anyway, do it correctly. This obviously looks wrong. So if you get this, you'll know that your answer is wrong. That you'll know that it's not good. And later we'll get to do the actual quadratic regression in here, which will always look perfect and beautiful. Well, not perfect, but it will look better. But put your equation in, and it should, at least hopefully, that would be a negative, I think. I don't know if I can get it to, oh, that looks worse. I'm obviously not doing something right, but when I'm making up my numbers, one should not make up numbers, right? Don't make up numbers. Actually do the work. And you will, ooh, that made it bigger. Let's try that. Nope, too far. Anyways, you can see I finally found the number that would help me get it up where I want it. And that, see, now we're talking. So, don't play with it. Actually do the work. And when you're doing the work, I was typing it. You can do it on a piece of paper and take a screenshot and put it, or take a picture with your camera and put it in. I'm fine either way. I do want them embedded though. I want one document. That's really important when it says a written report, 2 to 3 pages, double spaced, which I didn't get to the formatting yet. That is how it needs to be submitted. It needs to be double spaced. It needs to be a written report. I don't want you just, as I said, I don't want you writing number 1 and then talking about running. Make sure you write it as in paragraphs, make it nice and neat. Introduce your introduce what you're putting in. You know, if you're going to put in a table, put in a table. But tell me what you're putting in. If you're putting in a scatter plot, tell me what the scatter plot is, and then answer all of these questions about your scatter plot. But don't just dump it in and be like, and then just start talking about it. Don't pretend like I know what